go to finding x equals c that satisfies the mean value theorem. So recall, the mean value theorem says that if f is continuous, on the closed interval AB and differentiable on the open interval AB, then there exists some C in the open interval AB such that f prime of C is equal to f of B minus f of A all over B minus A. Now let's go ahead and consider a specific example. Consider the function f of x equals x squared plus 3x minus 4 on the closed interval 0, 2. Our job is to verify that the mean value theorem applies, and if it does, find x equals c to satisfy the theorem. So to verify that the mean value theorem applies, we need to check that f is continuous on the interval 0, 2, which f is a polynomial, so this is definitely true. And so f is a polynomial, so it's continuous. And then we also need to check that f is differentiable on the open interval 0, 2. And again, f is a polynomial. So it's differentiable. And then what we're going to do is we're going to actually find that x equals c. So we need to find x equals c such that f prime of c is equal to f of b in this case is 2 minus f of a in this case is 0. So f of 2 minus f of 0 all over 2 minus 0. So the first thing we need to do is find f of 2 minus f of 0 all over 2 minus 0. But f is x squared plus 3x minus 4. So recall f of x equals x squared plus 3x minus 4. So we have that f of 2 is equal to 2 squared plus 3 times 2 minus 4, otherwise known as 6. And f of 0 is 0 squared plus 3 times 0 minus 4, otherwise known as negative 4. I need to give myself more space. So at this point, we can go ahead and then find f of 2 minus f of 0 over 2 minus 0. So we have, that would be 6 minus -4 divided by 2 minus 0, or 10/2, otherwise known as 5. So we're looking for f prime of c equals 5. So in order to do this, we need to find f prime of x. So again, f of x was x squared plus 3x minus 4. So that means that f prime of x is 2x plus 3. So we're essentially solving for where does that equal to 5, equal 5. And so that equals 5 when 2x equals 2, or x equals 1. And so the value of c we're working with is 1. For one more equation, let's go ahead and consider the function g of x equals x plus 1 over x minus 3 on the closed interval 1, 4. Again, we need to verify that the mean value theorem applies. And then if it does, find that x equals c to satisfy the theorem. So again, we need to check first that g is continuous on 1, 4. So rational functions, the only place that could be an issue is if the denominator is equal to 0. So for a rational function, we need to check that the denominator does not equal 0 on our interval. So the denominator is x minus 3. Where does that equal 0? Well, that happens when x equals 3, which is in 1, 4. And so we have that it is not continuous on the interval. So it's not continuous on 1, 4. And so that tells us that the mean value theorem does not apply. So we do have to check the conditions are met for the mean value theorem. Check we have continuity, check we have differentiability. The main places that will have issues will be things like on the in rational functions, the denominator can be an issue. We might have issues with like secant, cosecant, cotangent, tangent. All of those have asymptotes. So you have to verify that we don't have an asymptote in the interval. And then piecewise functions can also cause issues. Piecewise function could be a case where we have continuity but not differentiability. So just things to watch out for. But if the conditions are met, then find the derivative, find where that matches that average rate of change, and then you have your C.